This presentation is on SARS-CoV-2, classification, variants, and genomic surveillance. This presentation is by Miranda, Tommy, Pete, Mila, and Alexa. What is COVID-19? COVID-19 is a severe acute respiratory syndrome, and it is a positive-sense single-stranded RNA virus. COVID-19 is also known as SARS-CoV-2, which is a type of coronavirus. Coronaviruses are a family of viruses, and 7 have actually been identified. A new coronavirus can emerge when an animal coronavirus develops the ability to transfer a virus to humans. SARS-CoV-1 versus SARS-CoV-2. SARS-CoV-1 first emerged in 2002 in China and was subsequently first identified in 2003. Transmissions mostly occurred in the healthcare settings due to the lack of adequate infection control precautions. It typically causes severe symptoms related to the lower respiratory tract. It lasted from 2002 to mid-2003, and over 8,000 people got the virus and 774 people died. SARS-CoV-2 is a virus that causes COVID-19. It was first identified in 2019. It is transmitted more easily than SARS-CoV-1 and can be transmitted by people who are not showing symptoms.
So moving on to the structure of COVID-19, we've included an image to the right which helps a lot in the overall understanding of it. But basically, coronavirus is an envelope virus, which means that there is a core of tightly packed RNA or genetic material surrounded by proteins and lipids, and these proteins and lipids are what provide structure and assist in other functions like making new viruses. If we're taking a closer look at these proteins, there's first the nucleoproteins, which we see right here. These give the virus its structure and enable it to replicate. There's envelope proteins, which we see up here, which aid in the assembly of new virus particles after the virus has infected a new cell. Then there's the membrane proteins right here, these brown ones, which can bind to all other structural proteins. And then on the outside here, we see the spike proteins, and these are actually what help the virus, or allow the virus to bind and enter human cells. And these spike proteins are actually what gave coronavirus its name because of the shape of them, look like a crown, so coronavirus.
So now for the variants, we have the Delta variant, which was first discovered in October of 2020 in India, and it has 23 mutations from the original Alpha COVID strain. And then we have the Omicron variant, which was first discovered in November of 2021 in South Africa. And as we know, this is the most transmissible variant, infecting 3 to 6 times the amount of people as Delta. And the symptoms of these are pretty much the same. And then we have the Alpha variant, which was first identified in the United Kingdom in November of 2020. And as of July 13th, 2021, more than 160 countries have reported having an alpha case. And then on the right, we have a map of where all the different variants come from. And as we see that the World Health Organization did not want to single out any countries, and that's why the variants aren't named after the countries in general, and that's why they're named after the Greek alphabet.
What is genomic surveillance? Genomic surveillance is a system for scientists to track and keep up with the different type of variants that have come out from the COVID-19 pandemic and the different variations that will come out.
How genomic surveillance works. Scientists sequence specimens from people who have recently tested positive for COVID-19. Scientists use genomic sequencing to decipher the genetic material found in an organism or virus, and they have to wait a slight grace period before analyzing the sample from the patient. Unfortunately, this process takes a bit of time to analyze because the wait usually ranges from a couple days to a couple weeks. And on the right, we see that you get an infected person, you take a sample from them, and then you locate the targeted segment and put that through the sequencing machine, and then after that you're able to compare it to the known variants and then finally identify what type of variant that infected person had.
Genomic surveillance is important because it will help scientists be more aware of the current state of the disease, which will help them better prepare for the future. This is extremely important because we need to know what is ahead of us, and the more we prepare and find it sooner rather than later, the more it will help us in the long run. And these are our sources. Thank you.